It's Monday night, 11:30, July 11, 2016. This is supermushmouse. And that there is the moon hologram. Okay, I took some photos and a video with another camera before. This is the normal camera before. So I didn't have the zoom that I have with this one, but it does take good photos, so we'll see what this one shows. There's a lot of large orbs all over this whole side, from top to bottom and bottom to top, and I caught them, I believe, in the camera before, shooting beams of light. I think they're all shooting beams of light. I'm just going to try and verify that. Yeah, that was shooting a beam of light. They're much longer than just that little bit, because before they were shooting it right at the other, I mean at me, at the other camera that I had. Okay, so you have to get them just at the right angle to catch it. The other camera was able to get them like where they were shining. Okay, they're really highly active. The whole thing is highly active. Look at that. See how fast that's moving? See that orb there spinning? Man, all of them. They were shooting so much light before, right at my camera, and they were blurring the whole thing. But this one is on electricity, it's not on batteries, so you can't do that to this one. Look how fast they're spinning. Okay. Man, they're in hyperdrive right there. Okay, so those are orbs, or those billions of other ones right behind them and all around. The entire moon hologram is just like that. These you can see as an example what the rest of them look like and what they're all doing. Like these ones out here, the billions of them, the billions, I mean the entire universe of them. And look at these. And when I go in too close, you get a better view from like farther out. You can get a grasp on what's going on. But that's what looks like spaceships, okay? But they're like living, organisms. They're alive. Okay, those are not spaceships. These are multidimensional living beings, and they live in clusters, or they form clusters. Whatever they do, they always do as a cluster, a whole bunch of them all in a bunch. And our whole, what we say, call the moon, is a big cluster of them. Look, they're all over it. I mean, the whole thing is made out of them. Okay, you see? There is no moon. That's it. It's just them. So it's them and us. Hopefully us is not them. it's really them and us, and not them is us, or us or them. You know, but man, they're really going tonight. Yeah. Okay, so. Okay, so there's been a slowdown in the velocity of the revolutions, somewhat, not much, but there's been a shift in how fast they're moving, definitely. Okay, so the velocity's been slowed down. That means the frequency is lower. I mean, the vibrational frequency is lower, but these are still going pretty fast. But not like before. Okay, they're not as fast as before. They were really moving before. Okay. Look how the moon hologram, you could see right through it right there. Okay, see? It's not a solid object. It's just a bunch of them creating the illusion that there's something there. And that thing that I thought was a wall with the other camera was just orbs all lined up, but they're big ones. But it's not. I thought it was a wall with the other camera because I couldn't get close enough to check it out. But you see, it's orbs. Just a bunch of orbs. Look at this line of them right there going horizontally. So one's going horizontally, the other one, it's vertical right into space. You see that line going up? That's vertical, going right into space. And the other one is horizontal. Okay? And you could practically see right through it in some places. Like, not there, but over here. You could practically see right through it right there. So the whole thing is just a holographic image, you know, presented. I gotta loosen this. Yeah, I lost the whole thing. Okay. Yeah. I have to move this carefully because it's in high zoom. Not all the way, but it's pretty high. Closer now. I'll just let it sit there for a second. Okay, so you see the line going right into space, that big line of them? That's like stacked up straight up into space. And that's a long ways out. You know, that's a long ways out. Okay? It's not just a few miles. That's like hundreds of miles out. You know, maybe even close to 1,000. And then you see the structure on the bottom. Okay, it's a line, but then you have a geometric type configuration right there. Okay, that's a ring of orbs on the left. On the right is just the orbs in a line, but that's a ring of orbs on the left. And then you have this thing sticking out right into space. Okay. I'm sure they're, you know, like a radio tower or something. There's no other reason that should be sticking out like that. You know, it's like a communication antenna of some sort, but none that we have. And this is like an energy setup, and it's made out of them. They just line up into a structure and a formation like that and create an antenna. I don't want to go too fast. Let's check them out one by one. See how fast they're shooting off? Okay. Those are all those blue little flashes you see. That's the energized ones going off from the nucleus there. That's the moon hologram. That's the nucleus of the larger cluster. It's all these fast frequencies and, you know, rotations and revolutions that create all that energy that looks like that, you know. And that's our moon. It's an energy cluster because of all of that. Look how fast these three are churning out. They're like dynamos. But before they were shining like beams right into my camera. And really, I couldn't get the right angle because it wasn't just them doing it. Now that there on top, that was doing it too. See that little light right in the center of it? That's not a little light. When it gets you right at the correct angle, it's blinding. Like they all have it. You just have to get the right. I moved the camera over from the other position because at the other position they could shine right onto the camera or right into the lens so that you couldn't see anything. Look how fast they're moving. See how they stream? There's zillions of them. And they're all doing the same thing. Okay, see how they stream in lines like that? But for every line you see, there's like a million you don't see. You can only see them in some places, not everywhere. Like when you come out here, that's a lot of lines. Okay, this is like what space is like. I know they say it's so wide and everything, but I don't know. It's hard for me to believe that that's true. Okay, I don't believe anything that science says anymore, because look, this doesn't look like any void. To me, it looks like a lot of living things just all over, and a lot of energy out there. See the flashing? They're energizing themselves. They don't even need the moon hologram anymore. Look, there's going to be another one right there. See that? All that energy just being created right there on the spot. Okay, so these are really charged up tonight. They all are. It doesn't matter where I go. I just move the camera like, you know, 90 degrees over. Look, everywhere. I don't know what happened in the universe tonight, but at least this part of it is fully charged. Look at that. Man, no matter where I go, I just went up 90 degrees. Look, the whole thing is charged. Absolutely. Absolutely. Okay, so either there's been a big explosion somewhere, like, you know, that we can't see, or it's too far for us to see, but something must have happened. Maybe a star exploded, or something like that. Or it could be a black hole coming up. I don't know. But something's got them all excited. And they're, man, I have videos of this from previous times. I don't think I ever had one where they're all like flashing white like this, no matter where I put the camera. Now I'm all the way on the left, like another 120 degrees. I'm just going all around, like to check it out. It's unreal. I'm going like I'm almost straight up with the camera. I'm over 100 degrees from where I was before, going straight up like overhead. I'm gonna put it back. Okay. Hold on, just take the zoom off so I can find the moon hologram. I'm so far out. Okay. I got too much zooming. I gotta get back. Okay. Okay. Okay, that's the building. Okay, that's a airplane warning on the building below. That flashing light on the bottom. Okay, there's the buildings. Okay. So concentrate on the moon hologram, because it's going to go out of sight pretty soon. It's going to go behind the building. A different building. Okay, so I'm trying to see if that maybe that blue star thing is around it. Man, everything is charged up. Okay, you can see it even from far away. You don't have to come close. You can see it even from like this distance. That everything is like charged up. Like not just the atmosphere, but in space, all the orbs are charged up. Okay, I don't see the wormhole there tonight. I don't see it. So that can't be the reason, because it's not visible or anything. Unless they found a way to make it invisible, since they found it. But I don't think so. Those things aren't that easy to change. Okay, here it is from far away. You can see the orbs are like just in a blistering like speed. Look, all over the whole thing. They're not only going around it fast, but inside of it too. They're like just super fast. Set it up and lock it in. Not high enough. Very easy. Okay. See that electromagnetic field there in red? That's just orbs. That's how fast they're going around the whole thing. Okay, so when they do that, okay, when they spin like that and fly, that's what looks like a flying saucer. So you have the roundness of the orb, and then you have the other orbs going around its side, like circling it even faster than what the orb is spinning on its axis. And that's what looks like a flying saucer. And it seems like it has a disc around it. Okay, so that's how you get the idea that it's like a machine, but they're all alive. There's no machine. They are they're the machine. And this is all like living things. Look at them. You see how many there are? Okay, here's a good look at the dark ones. Okay. So I have a different angle now to show you. Here's the dark ones. I'll show you where the energy comes out. Okay, you see those little white flashes like that? There's a lot of them happening. Every time orbs come together in a certain way, as they spin on their axes, as they revolve around in like a zillions circular patterns, and all those circular patterns happen to be in a square, because if you look at it from like a further, I don't know if you can see it from here, but like from there, you can see that they are squares, and it's like circles and squares. And if you take a good look at this pattern, you'll see that it's a grid. Okay, so they follow a grid, and those orbs interact with like a multidimensional grid. So it's like tons of these grids all mashed in together, and orbs spinning like that in circles around each one of those squares in each one of the dimensional grids. They're all dimensions, so like that's why they never collide. None of them are in the same dimension. When they come into contact, that's when they're in the same dimension, and they never come into direct contact. It's the proximity of the orbs and their charges that make that spark. Okay, where's the spark? Okay, you see that white light like that happens every now and then, the flash? I don't know if that's a good example. But, okay, you see those white flashes that are happening all over? Like flash, flash, flash all over? Okay, well, that's when the orbs come into the same dimension, and then come into proximity, because they can't touch. If they touch, that's not good. They'll collide and explode. Even if they come too close, they have to be just at the right separation distance from one another, so that nothing happens except the energy is released. Otherwise, it's big trouble. If there's one accident, it'll be like a big collateral damage in that whole section. Like all the dimensional fields will collapse, and so will that whole area where it happens. So it'll damage that entire, structure in all the different dimensions that are involved in that particular release of energy that's happening in that area. So they can't collide or come too close. They have to be just right. Just like when I try and get a correct angle, it has to be just right. It can't be, you're getting a little off. It's no good. It has to be absolutely right. And so that's what they do. So here's the grid. Okay, if you look at this closely, there's a grid between the black orbs and even the blue orbs. They make a grid, but they move too fast, so you can't tell. I mean, you can tell if you look at it long enough, but with the black orbs, it's easier. You can see the grid pattern if you look at the black orbs. You know, don't look at the other ones for a minute. Just look at the black ones. Okay, and you'll see a square pattern. Okay. So within each one of those square patterns, you have like a ring. If you watch closely, you'll see like a ring of orbs, but it's not just one ring, it's a lot of them moving simultaneously, and they're all moving in different counterclockwise directions, but they're all counterclockwise. So it looks like an atom, but a whole lot of them, you know, like with the electrons and all spinning all around the nucleus. So the whole thing is like that. The whole universe is like alive like that, with all these atoms. But you know, they're not just matter. It's these organisms are alive, and they're smart. You know, they can think, and they can do things. They don't just spin, you know, like crazy like that for no reason. There's a reason for it. They're creating energy by doing that. And then when you get to the moon, which is like really far away now, I'm going to get to it. I got to back off first. Backed up too far, so I have to make adjustments. Well, that's a lot of orbs moving very fast tonight. Now you can really see them. There's no doubt about it what they are. Okay, they're all living organisms, very, very intelligent, every one of them. You know, all the zillions of them, just in the moon hologram alone, let alone in space. And all this has a purpose and a meaning. It's not meaningless. All this spinning and everything, it's all about energy. Everything is about energy. Okay. Electromagnetic energy. Boy, Nikola Tesla didn't know how right he was. He had to imagine all of this. I know he didn't have a camera that could see it. He could probably imagine all of this in his mind. So it's electromagnetic energy. That's what powers the entire universe. And that's what these things are busy creating with all this spinning and all this velocity and all this movement. Okay, and all their circular patterns and all their squared grids and everything, the whole setup, the way it works. It's all about creating electromagnetic energy, and that's the force, I mean the energy that drives the entire universe, and that's what makes it work. And it's intelligent energy making energy, if that makes sense. So they're perpetuating themselves. It's like a perpetual motion machine, except it's not necessarily made out of matter, although some matter is a byproduct of this whole thing, and that's how we get planets and solar systems and all that. But it starts off, and I guess it ends with energy, because the whole thing is all about energy. Without it, there would be nothing. Because nothing would happen and nothing would be created. And if it can't be created, it can't be destroyed, because there'll be nothing to destroy. So it's energy that's the key to everything, and it's the kind of energy it is. It's electromagnetic, and you're seeing it being made right now. And I'll get to the flashes over here where you can really see it. Okay, watch the flashes. Okay, I took out the brightness just with the angle. Okay, angles are very important when you're taking like video Orion photos or anything in space. It's all about the angle and how you work the light, because camera is an instrument that captures the light, and if you don't know how to work the angles, you can't capture the light properly, because you're not at the right angle or in the right angle position to do it. So it's all about how you look at it, from which angle or the angle you take on it. That's the result you get. So this is the angle I'm taking on it, and these are the results I'm getting. And this is in space, and this is energy being created right in front of you in space. No matter, I'm moving the camera actually, so you could see it there. You could see it more here on this angle, right there in the center. You see all the flashing. So some angles show it better than others. You have to get just the right one. So there's energy being created all throughout the universe, big time. Those blue flashes are, releases of energy as well. But the white flashes, they're like very concentrated energy. Okay, blue are also high energy, but not as concentrated as the white flashes. And then, it goes down the color scheme accordingly. But you can see that it's being created throughout the universe, and it doesn't have to be just in a huge cluster like the moon, hologram, or our sun, or any other star, or any other cluster for that matter, like a large orb cluster or even a small orb cluster. I've shown them all over the last, I don't know how many years I've been doing this, at least 6, maybe more. I mean, with the camera, I've been putting it on YouTube at least 6 years. So that's a long time. Since 2009, I've been putting this on YouTube, on my channel. And this is what it's come down to. How energy is created in the universe by organisms that are alive and smart, not by, some reaction that's, physical or chemical or mindless. It's actually organisms making it. And that means that the whole universe is alive, and even a bigger organism than just these ones that you see here, because they make it up. The whole universe is like that. And then you get to a thing like the moon, which is going to be out of sight any second. When you get to it before it does go out of sight. As soon as I get the zoom back far enough to find it. Good enough so far. Okay, I'm still moving the thing back. Too far, okay. It's almost gonna sink and go behind a building. Okay. See, even the moon hologram is far. It takes a lot of zoom to get to it, and that's the closest thing to us in terms of things in space. Unless some rock comes in real fast and gives us a surprise, but other than that, this is like the closest thing, and look how much zoom it's taking just to get to it. Okay, so that's what I wanted to show. When it goes low down to like almost horizon line, or just above the horizon, then you can really see the orbs. Okay, something about that lower angle shows you the orbs, like just how many there are. There's many more than that, but at least here you can see them. They're everywhere. You see them shooting off the surface there. Okay. Okay, you see some coming in, some shooting off. It's like an endless cycle. They come in, charge up, shoot off, and then the ones that are charged up make even more energy. Okay, now you can see what the moon hologram really is. Okay, it's just orbs. Yeah, tons of them. All that. Okay, here it is. Okay, that's why I call it a hologram. Because all those features like craters and everything, that's just, these things can change color and they can change the depth and even make structures and everything, and they create the illusion that it's an object, but it's just them. Like the whole thing is just them. There's nothing solid there. They're all in motion, and they're really moving. I mean, they're moving faster than any bullet, and they're large. These are like 100-mile objects I mean, sorry, not objects, subjects or entities, intelligent too. They're just all over. You see how, as it goes close to disappearing, you can see different colors and everything. That's because of the angle. It's going to disappear very shortly. Okay, now you can see that its orbs in that electromagnetic field there on the outside. Okay, see that on top there in the red? You can see that its orbs shooting real fast, one after the other, just streaming. Okay, and they create that electromagnetic field because they're not just charged orbs, they got radiation and everything. So that's like a radiation field and a whole thing. It's charged, highly charged particles, but these particles are like 100 miles each. They're not small. Okay, so they create that electromagnetic field that prevents all of these other ones from just rushing in and just eating up that energy in the nucleus. And that's why you can still have the hologram, because to a degree it's protected, but the ones that really need a charge, they get in and charge up, and then they have to leave and make room for others. So this is it. This is your the object, or so you wish that you could call the moon. Okay, it's alive and well, and it's all these organisms. They're energy organisms. I have to call them organisms because I don't know what else to call them. They're alive, they're living beings, and they're energy, and they're smart enough to create like energy and remain in an energy state, but if they choose, they can turn that into a physical state and become real physical, either things or beings or entities or whatever you want to call them, and then they can take any shape and form and color and all that. So really smart. That's all I can say. And there's a whole lot of them out here. Okay, the moon hologram is gone. I can't get anything much out of it now, just orbs. But I want to show these orbs. Okay, this is really looking far out. So now you're looking back in time, because this is really far out. Okay. See, even far out, there's energy being made. No matter how far back you go, there's energy. Okay. Now the energy that far back, okay, it doesn't, there's some like strong, there are white flashes, but not as many like from that far back, because by now they've lost their what do you call it, not their potential, but their strength, because it's happened a long time ago. I don't know how long ago this is, but it's pretty long ago. This is like pretty far back in time, because this is in distance very far. Because I got a whole lot of zoom on now, and this is like really far. So this is like I maximized it, and so you see the difference in how much white flashes there are from back then. That's because by now they've lost their strength. But if I could go like even deeper, the ones that you see now would come out bright white, and the ones behind them further back in time even, they would look like this. So no matter how far back you go, you're always going to find energy. It's always going to be there. Okay, it's just that I'm limited with how far back I can go with this camera or any camera, and that's the reason you only see some flashes that are white. But like, see, as soon as I come closer, you see more. You see? And I backed up. But you see, these are more recent as I back up. Like, okay. Now there's a certain point if I back up like too much, like this, then you can't see them. I'm too far back. Because now I'm not close enough to see them. So there's like a fine line between being, too close, too far in, or not close enough. And you have to like work it from there. Okay, but like you see, this is like more recent. Okay. See, the flashes are stronger than like if I move in closer and going back further. Okay. So now, okay, you see some white flashes, but not that many. Let's see, I move back. They all look white because it's more recent. Okay, they're brighter anyway. They may not look white. I don't know how the camera is going to capture them. They could be like very light blue or flashing blue or something. But it all depends on the chip and how the camera captures this angle. If I let's see. Let me just try something. I'm changing the angle. Let me just loosen it. Okay. See, at this angle, they're even brighter. See, even brighter. Okay, depends what angle you're at. Letting the camera run all the way. Now it's straight up. Okay, I just let it fall, free fall. Okay, so now I'm going back. Okay, so it's happening everywhere. Okay, it's the same everywhere. Some places there's more energy than others, but tonight was a busy night on the moon hologram, which is gone now. It's gone behind the building. I only have a certain time period I can see it, not for long. But that's what I'm talking about, the energy. It's being created with or without the moon hologram, or our sun or any other thing. It's just being created with these organisms all over. Okay, and the universe is not a void. Whoever said that didn't have a camera or any other means of detection. but you can only detect these things with a camera. You can't detect them with anything else. I don't see the scientists saying they're detecting them with anything else, unless, you know, they just don't want to say so. But for a normal person, you can definitely detect them with a camera if you know how to use one. I just want to get a shot of that star that I did the other night with the other camera, where I trapped it. I want to see if it's going to pull the same thing on this camera, or if it's not capable. So first I gotta find it. That's rule number one. Find the star. Okay. Okay, so. Okay. The brightest star in Orion, and it's somewhere around the head, but not quite in the head. I don't know. It's one of those up front. Okay. It's definitely a big star. It's visible by eye. And, I just want to see if it's going to pull the same thing on me that it pulled with the other camera. Or if it's not able to because I have an electricity. Okay. Boy, it already knows I'm going to film it. Don't ask me how it knows I'm going to do it. I didn't even come close yet. Man. Okay. Alright, it's back to normal. That is a warning. Okay, so it knows already I'm going to film it. That was a definite warning. It's traveling very fast. Okay, that's the angle I wanted at, so I get the real thing. Okay, now see all the radiation? Okay, it's doing that on purpose because it's hiding all the orbs there going around it on the outside. I went too far. Okay. I'm gonna get the thing in the right place. There. Okay. See all the orbs going around? It's trying to hide them in all that radiation. Okay, the whole thing is made out of orbs, but it's just like the moon hologram. It has that fast, like a chain of orbs around, creating that electromagnetic field, and that's radiation when it's in red. Okay, that means it's really high intensity. electromagnetic energy. Okay, it's very high intensity. You can see that the orbs are moving very fast around, counterclockwise, and in the nucleus you can't see anything because they're moving so fast. You see, just can't see anything. Let's see if okay. Okay, so it's not able to pull the same stunt that it pulled on the other camera. It's able to change itself, but it's not able to like, you know, go smaller, go back and all that. Because this camera keeps it where I have it, you know, at the zoom that I have it. And the other camera can be controlled because it's on battery. Or I had it on battery last night. And the night, that other night that I put the video out. See it change right there? That's how it changes the image on the other camera, by increasing or decreasing the frequency. And that happens by the increase in velocity or decrease in velocity of the orbs. And you can see the ring there in the center of the nucleus. Look how fast that's spinning. See the center of the nucleus? There's a ring spinning right around the very center. So it's like a ring within a ring within a ring. Okay? It's like a bullseye. I don't know if you can see it. And I hope it shows up on the video. Otherwise I'm talking for nothing. Anyway, what I see here now is a ring on the outside, the red one, then the green one with some yellow, and then the white nucleus, and then in the center of the white nucleus another ring, and then the very center. And all the spin is counterclockwise in all of it. It's very fast. These are huge orbs. These are like larger than Earth-sized orbs going around that thing, because this is a big star. This is like Jupiter-sized orbs spinning around at that speed. Maybe even larger. I don't know how big the star is exactly, but it's a lot bigger than our sun. A lot bigger. Okay, so let's see if how the energy production is in this part of the universe, besides the star. know that's producing energy. Let's see. Let me move it around a little bit. Yeah, it's happening all over. Even, and that's another constellation altogether. That's Orion. But even there, it's the same. It didn't matter, or it doesn't matter wherever I point the camera, I get the same kind of thing. So the universe is pretty much, it's not the same, but it's pretty uniform, at least in the way it creates energy. It's these orbs and their interaction and their counterclockwise movement and velocity and the spin on their axes that's also counterclockwise, and their pattern, the square pattern that you can see right there. I'll move back a little bit. There's a square pattern. I don't know if you can see it. Okay, there, it's like a grid. Okay, it's square, and because they move, sometimes it looks like it's a hexagonal pattern, but it's really square. It's just that it's all in so much motion that it appears hexagonal at certain times in the motion, but it's squares and circles, and then everything else comes from that. But it's squares and circles, and it's circles within the squares, like the orbs are going around in circles. But if you look at the orbs and connect them into circles, they're always moving within a square. And it could be many small squares making one large square. It doesn't matter. It's circles in a square, or a circle in a square, or lots of circles in a big square. Either way, it's circles and squares, and it's a grid with circles and squares. Okay, so the whole thing is moving, and that's what makes it a multidimensional space, because everything is moving. Nothing is in one place for any amount of time. They're moving at very high velocity, and all the movement is counterclockwise. So I don't know exact reasons for why it's counterclockwise, but I think it's because it's always moving back in time, and time is cyclic, so if you move far enough back, you get to the future. Like, at least that's the way I see it. But I think the reason for counterclockwise motion is because everything is going back in time. Because with the camera like this and the zoom and everything, you're always looking back in time, and that's why everything is in a counterclockwise progression, because everything is going back in time. The distance and the movement and the whole relationship with you and the distance, and it's all about location. It's just like if you're looking for your home, it's location, location, location. So but that's the reason for counterclockwise movement, in my opinion, because you're looking back in time. And so everything is going backwards, and I think if you look far enough backwards, you get to the future, because these things travel so fast that to them the future, past and present is all one thing. That's how fast they can move. So they have no like time, they're always in the now, and that's the reason It's the speed. Okay. The velocity of motion. Okay, that's what creates a no time zone, like everything is in the now. So I don't know what kind of experiences they have if everything is now. So yeah, they must get a whole. They have to be able to process, like, you know, the past, present, and future all at once, and be all different places all at once. I don't know how that works out because I've never done it myself. So it's something to think about and what that would be like. That, you know, that's interesting to think about what that would be like. You know, to be able to do that and to be aware that you're doing it, which these things are, and I don't know. Anyway, that's what we're dealing with. That's what's coming over here, and that's what all these sightings and orbs and all these illuminated round objects and all that can turn into a physical thing in a minute or in a second. That's what they are. And they can be any shape, color, form, living or non-living matter. Doesn't matter to them. It's all the same because they convert energy into any kind of matter and into any kind of shape. So they could do anything they want. And that's pretty good. I wish I could do it. But unfortunately, I'm not that gifted as they are. So, you know, this is not just little balls in the sky. These things are huge. They're, you know, these right now are bigger than the Earth. Every one of them. That's how far back I am. And those are big. Okay. That's the Orion constellation. Okay, so if you can see them, they're big. Okay, they're like Jupiter size, at least. And you see the flashes there of the energy? It's happening everywhere, throughout the whole universe. It's all the same. And it's the same kind of deal. Yeah, see the pattern? Okay. It's like a very complex atom with a lot of electrons exploding all over. Okay, right there in the center. If you look at that center, it looks like a very complex atom. You know, all these electrons changing fields. Just you can't see how they do it, but they, you know, they're here, they're there, they're all over the place, and just, you know, illuminating here and there and gone. And that's just the speed that they're normally at, and that this is their normal life. And their energy beams. Look how fast that is. It's mesmerizing, to say the least. Okay, so so much for the universe being a void. I've never seen so much life in my life. That's a lot of living, intelligent things out there. And they're all alive. I don't care if they're energy. They're still smart. And you know, they want to come down here and be something in a physical form and really big. There's a lot of them that can get together into a cluster and be something big. I mean, really big. Bigger than any city on this planet. Bigger than the planet, you know, so nothing to take for granted and nothing to ignore and nothing to laugh at for sure. Okay, that's it. Thank you. Have a good night. This is supermushmouse. Thanks for viewing.